Hello everyone, we are Group 5. Design of a multimodal, human-robot interaction robotic arm system. The traditional robotic arm section. They are mostly used for repetitive tasks in industry, and they lack the ability to make judgments and learn. Their human-machine interfaces are quite complex, so it's hard for them to fit into everyday life. The changes brought by AI technology, image and speech recognition technologies, have become increasingly mature, which lay the foundation for natural human-machine interaction. The widespread use of voice assistants has increased users' acceptance of and expectations for interactive technologies. As artificial intelligence continues to advance, we hope to overcome the limitations of traditional robotic arms in human-machine interaction, so that they are no longer used only in industrial settings, but can also be integrated into everyday life, bringing greater convenience and efficiency. Therefore, this project will develop a robotic arm equipped with speech and vision capabilities to achieve intelligent operation, enable the robotic arm to transform from a tool into a companion in daily life. To realize an intelligent robotic arm with speech understanding and visual judgment capabilities, this study sets for objectives: establish a voice-driven intelligent interaction system, improve the accuracy of robotic arm operations, integrate voice and vision to control the robotic arm, verify the feasibility of intelligent human-robot collaborative applications. First, the part on establishing the voice-driven intelligent interaction system uses ASR and TTS to implement a natural spoken communication interface. The part that improves the accuracy of robotic arm operations combines YOLAV 1.2 with the Intel RealSense D435 to perform real-time image recognition, integrating voice and vision to control the robotic arm. It's done by controlling the ARM 5 with Python to perform actions based on speech and visual data. Finally, to validate the feasibility of intelligent human-robot collaboration applications, in order to demonstrate the intelligent control and interaction potential resulting from the combination of voice commands and visual perception. Here we divided the work into 3 parts, namely voice, arm control, and image recognition. The voice part. For ASR we use the Google Speech API. For TTS we use PIT3 for spoken feedback. The function is to parse intents and report the results. The arm control part uses an ARM 5 and the gripper, and is controlled with Python. Its functions are to perform grasping, placing, and moving actions. The image recognition part uses an Intel RealSense D435 depth camera combined with the YOLAV 12 algorithm to perform real-time detection and output target object information. Practical operation flow of the robotic arm combined with voice. First, the user issues a command through a microphone. After receiving the command, the robotic arm begins the grasping action. Finally, the robotic arm moves the object to the location specified by the user and delivers the item according to the instruction. The operation flow for image recognition is: the user issues a command through the microphone. The D435 works with YOLAV1 tool to capture images and perform detection. Let's watch the actual operation video.
智慧助手，
我在，需要做什么？
请帮我拿保特瓶。请帮我拿卫生纸。